Last time in 12.2, we talked about the arithmetic sequence. Now in 12.3, we're going to talk about the geometric sequence. And it's going to be similar to what we did in arithmetic, but instead of having a common difference, we're going to have something a little bit different. Now, with our geometric sequence, instead of having a common difference, like I said a minute ago, we're going to have a common ratio. So the ratio of any term to the previous term is constant. Okay, so the difference is not going to be a positive or a negative, a positive 2 every single time or a negative 5 every single time. The ratio between the two is going to be the same. Okay, so ratio is not adding or subtracting like we did last time, and that's the difference. What does ratio mean? Ratio means you have something divided by something. So ratio, you have to divide to figure out if the ratios are consistent and if it's geometric. Okay, so let's look at our first one. Decide whether this sequence is geometric or not. Okay, so we have to decide, does the ratio stay consistent? So the ratio between 2 to 1, what is that? Ratio of 2 to 1 is 2. The ratio of 6 to 2. The ratio of 6 to 2 is 3. The ratio of 24 to 6. 24 to 6 is 3. The ratio of 120 to 24. 5. Is that consistent? It has to have a constant ratio. Does it stay the same? No. So this one is not geometric. We went from 2 to 3 to 4 to 5, so this one's not geometric. Well, how about the next one? What's the ratio between 27 to 81? 27 to 81 has a ratio of 1/3. How about the ratio of 9 to 27? 9 to 27 has a ratio of 1/3. How about 3 to 9? 1/3. How about 1 to 3? 1/3. Is there a common constant ratio? Yes. And if I were to ask, if I come back up here to the top, this ratio is going to be denoted by R. If I were to ask, what's R? R would be 1/3. Okay, so with our arithmetics, we had a common difference, D. With our geometric, we have a common ratio, R. Okay, so let's look at 24. Is it geometric, arithmetic, or neither? 24 to 6, ratio of 4. How about the next one? You got to check them all. You cannot just assume after doing 1 or 2. Check them all. 96 over 24. What's the ratio here? 96 over 24 is 4. How about the last one? 384 to 96. 384 to 96 is 4. So what is it? Arithmetic, geometric, neither. There's a common ratio as we go down the list, so this would be geometric. How about 25? Is it a ratio? 1 to 3, 7 to 3, 13 to 3. Is that going to be a common ratio? No, those are all different fractions. How about adding or subtracting? 1 to 3, you add 2. 3 to 7, you add 4. 7 to 13, you add 6. So is it arithmetic if we're adding something different every time? Nope. So 25 would be neither. How about 33? Find the common ratio of the geometric sequence. So they tell you it's geometric and they want to know R. What's the ratio? Well, how do we find the ratio? Write them out. 4 to 1. Well, 4 to 1 is just 4. Oh, I skipped one. I'm sorry. Let's look at 26 first. 26. Arithmetic, geometric, or neither? 4 to 13 is plus 9. 19 to 22 is plus 9. 22 to 31 is also plus 9. So if I'm adding the same thing every single time, this one would be arithmetic. And if they asked me, which they don't, but if they asked me, what would it be? The difference would be 9. Okay, let's go back now. Sorry about that. 33. Common ratio, 4 to 1. Well, 4 to 1, that one's easy. It's just 4. 16 to 4. It's also 4. 64 to 16, also 4. So what's my R? What's my ratio? 4. How about 35? 6 to negative 3. It's negative 2. Negative 12 to 6. Negative 2. 24 to negative 12. Negative 2. So what's your ratio? Negative 2. Okay, so looking for those ratios, looking for those differences. Now, going back to how to write a rule, we did this with arithmetic. Now we're going to do this with geometric, and it's going to be a little bit different. So this is our geometric equation, okay, and it looks a little bit different than that arithmetic one did. Now, in the arithmetic one, what did I tell you? Do you guys remember? In the arithmetic one, you needed what two things? You needed a sub 1 and d. You needed that difference. Okay, so take a guess. What are we going to need in the geometric? We're going to need a sub 1 still, but we don't have a d. We have an r. So it's the same concept, but arithmetic, we had a difference, so we need d. Geometric, we have a ratio, so we need r. Okay, it's the same types of questions, but now we have a different equation up here to use. So our example, write a rule for the nth term of the sequence, negative 8, negative 12, negative 18, negative 27, ... Then find a sub 8. Again, we're going to wait to do this till the very end. So write a rule. Now, look at the differences first. Negative 8 to negative 12. That goes up by 4. Negative 12 to negative 18 goes down by, the first one went down by 4. Negative 12 to negative 8, down by 6. Negative 18 to negative 27, down by 9. Okay, so that's not a difference. It's going down by a different number each time. Now, first thing is you got to find the ratio. Okay, what is that R? If it's not a difference, it's probably a ratio. So how do we do that? Take negative 12, divide by negative 8. Negative 12 divided by negative 8 is 3 over 2. And then we could continue. Negative 18 over negative 12 would also give us 3 over 2. Negative 27 over negative 18 would also give us 3 over 2. So 3 over 2 is my R. And then what did a sub 1 stand for? That 1 told us it was the first term. So what's the first term in this sequence? Negative 8. Now, unlike the arithmetic, there's nothing to solve for in this equation. You literally are just plugging those two things in. Do not multiply these. You have negative 8 times 3 over 2 to a power of n minus 1. Go back to our rules from a couple chapters ago. This is negative 8 to what power? To the first. You cannot multiply these two numbers because their powers are not the same. So do not start multiplying negative 8 times 3 halves. Okay, that's going to mess up everything. You can't combine those because their powers are different. Okay, so we have our rule. Now go back to that last part that we skipped. What is a sub 8? Again, how do we find it? What does this mean? The 8th term. So we take n and plug in 8. So negative 8 times 3 halves to the 8 minus 1. Well, what is 8 minus 1? 7. So you type in negative 8 times 3 halves to a power of 7 equals negative 2,187 divided by 16. Don't be afraid of fractions. It's very possible that you're going to get fractions. Now, this next one, similar but a little bit different again. They give us the R, but they don't give us a sub 1, they give us a sub 3. Okay, but again, don't let this confuse you. It's the same concept. What does this tell us? It tells us two pieces of information. When n is 3, we get an answer of 5. So what does that mean? A sub n is 5. That's our answer. They tell us r is 2. And what's n? N is going to be 3. So we plug in what we know. A sub n is 5, r is 2, n is 3. Plugging these in is going to allow us to solve for that a sub 1 that we said we're missing. Okay, so start at the top. 3 minus 1 is 2. 2 squared is 4. Then how do I find a sub 1? I need to divide by 4. So 5/4 or 1.25. And again, what's the rule with fractions and decimals? If the decimal stops, then I'm okay with it. And in this case, it stops. It's 1.25, and that is it. But if the decimal continues, write it as a fraction. Okay, so either one is 5. Fine. So we already know our r, so write out your equation. R is 2, so that goes into our r position. And then again, you can use either one of these. A sub 1 is 1.25. So there's your equation. A sub n equals 1.25 times 2 to the power of n minus 1. And again, do we want to combine these two? No, you cannot combine those two. The bases are different and the powers are different, so they stay just like that. Now, noticing one thing about the graph, remember how would we do it? You take 1, plug it in, get your answer, take 2, plug it in, get your answer, take 3, plug it in, get your answer. Notice one little difference though. With arithmetic, what shape did we have? It was a constant difference, so it was a line. But with geometric, it's a constant ratio, so we don't have a line. Since it's a constant ratio, we have an exponential curve. Okay, so notice that little difference about the graphs. Now, a couple examples. Write the rule for the nth term. Okay, 39. It tells us it's geometric, so it helps us out a little bit, which we won't necessarily know here in a couple days, but it tells us it's geometric. So we know we're looking for r. Okay, so start out by finding r. How do we do that? Find your ratio. So we need to take negative 4 divided by 1. What's that? Negative 4. 16 divided by negative 4 is also negative 4. Negative 64 divided by 16 is also negative 4. So, since this is geometric, what's our general equation? Our general equation is a sub n equals a sub 1 times r to the power of n minus 1. So plug in what we know. We know r is negative 4 and a sub 1. A sub 1, remember, is our first term, so that is 1. So our equation, a sub n equals 1 times negative 4 to the power of n minus 1. Then the directions also want us to find a sub 6. Again, once you have the rule, this is easy. They want a sub 6. So take n and plug in 6. I want to know my sixth term. 6 minus 1 is 5. Negative 4 to the 5th times 1 is negative 1,024. Same thing, number 41. Again, they tell us it's geometric, so we know we're looking at our ratios. So 14 to 2, that's a ratio of 7. 98 to 14, ratio of 7. 686 to 98, ratio of 7. So plug them in. My ratio is 7. And what's my a sub 1? Where are we starting? My a sub 1 is 2. So a sub n equals 2 times 7 to the power of n minus 1. Last step again, what's this a sub 6? What's my sixth term? Plug in 6 for n. 6 minus 1 again is 5. 2 times 7 to the 5th power is 33,614. So again, very familiar, hopefully, very familiar to what we did with the arithmetic. Okay, the equation is different, and instead of looking for a difference, you're looking for a ratio, but it is very similar. Just don't get the two of them confused, and you'll always have the equations, but you have to make sure you understand if there's an R, you're looking for the ratio, and if it's a D, you're looking for the difference. Now, couple more. 45. This one's going back and making it easier for you. It says R, so you know it's a ratio, you know it's geometric, and they give you a sub 1. So all you have to do in this one is what? Plug it in. So a sub n equals 4 times 3 to a power of n minus 1. 46, same thing. There's an R, you know it's a ratio, you know it's geometric, and they give you a sub 1, plug it in. So 45 times 1/3 to a power of n minus 1. 47, a little bit harder and a little bit harder than what we did just a second ago. They give us R, so we know it's geometric, but they don't give us a sub 1, so we have to find it first, okay? So this is one of the ones we got to go one extra step. So we got to find it here. What does this tell us? This tells us a sub n is 72, and then we need to find a sub 1. R is 6, and we have n minus 1. Well, what's our n? Our n's going to be 3. Okay, so we have 72 equals a sub 1, R is 6, n is 3. You got to find that a sub 1. They didn't give it to us. 3 minus 1 is 2. 6 squared is 36. Divide it to find your a sub 1. So a sub 1 is 2. Okay, but to find the rule, we have to take it and plug it back in. So a sub 1 is 2. So where does that go? That goes into our a sub 1. And we already knew R was 6. So we have 2 times 6 to a power of n minus 1. And again, can I make this 12 to a power of n minus 1? Can you multiply those? No, those are not the same thing. Do not multiply those. Keep them separate. So again, you're always going to have those two equations, but make sure if you have a D, you recognize it's a difference, and it is not geometric. A difference is arithmetic. And if you have an R, it's a ratio, and it is geometric. Okay, so make sure you recognize which one goes with which. Because when we get to tomorrow's, you're going to have to tell them apart.